This is 4.6, day 2, part 2. We're now going to graph the cotangent function with the parent function, but it has the same characteristics. It's going to look like a snake, but my asymptotes are in a little different spot, and I'm going to save the explanation of why it's a different spot until the next slide when we graph its parent function. The A, the B, the C, and the D, we can change those from its parent function. The left asymptote is now going to occur in the parent function at 0 and pi. And then the period is still the same distance, pi over b. And the way I remember this is cotangent function doesn't go right-handed like I am, it goes left. So the snakes are going to flip direction. It's going to rise on the left side and then fall on the right side. So the snakes are going to be backwards. So tangent is one of your big three. So I'm right-handed, I raise on my right hand. Cotangent is the inverse, one of the inverses. So it rises on the left, falls on the right. So let's just kind of go through the discovery piece again and where these ordered pairs come from. We're not going to graph them all. To review, when we were dealing with the unit circle, with the cotangent, to evaluate the different angles around just the unit circle from 0 to 2 pi. To find the value of cotangent, we would do the opposite. Cosine over sine. Or, in ordered pair, cosine is your x. Sine is your y, where we're going to have vertical asymptotes at where those angles are undefined. So if we think about, we kind of already discussed it on the last set of slides for a tangent, where on the unit circle will we now have them undefined at? 0 and pi. The reason why, this is the order pair 1, 0, this is the order pair negative 1, 0. If I take cosine over sine now, so 1 over 0, I get undefined. If I take negative 1 over 0, I get undefined. So the two places that are undefined in the first revolution is 0 and pi. Are there more? What would be the next one? 2 pi. 3 pi, etc. So the difference when we set up our left and right asymptote is a little different. We set that parentheses equal to 0 and pi, where with tangent, we set it equal to negative pi over 2 and pi over 2. And the period is still the same. It's going to be pi over b. So the parent function will have a distance of pi. Let's graph this. So now our first asymptote will be at 0. So on the x-axis, 0 radians. The next asymptote will occur at pi. The distance between those two vertical asymptotes is the distance of pi, which is 1 revolution. So we construct our snake. So we go halfway between the two asymptotes, which is pi over 2. and we make a dot. If you want to think about why we make the dot, you can go up to pi over 2 on the unit circle. That ordered pair is over 0 up 1. Then you could take cosine divided by sine and you get 0. All right, so now we go the opposite direction now with cotangent. Our snake is now rising on the left and falling on the right. There is a first revolution of our cotangent function. Has that same distance of pi. Can we add on another revolution pretty easily?
Yeah.
Yep. Just add in another pi and make another snake. I think I'm going to skip that part since we just did that on the last example. All right. 2 examples left. Now I'm going to change it up on you. Maybe we'll throw a reflection in there. Maybe we'll throw a vertical shift change up or down. Maybe we'll change the length of the period from their parent functions. Those things happen again with tangents and cotangents. All right, so we want to graph the function negative tangent of 2x plus 4. So there are 3 changes from its parent function. So let's talk about the negative. What is the negative in a sine function? A reflection. Same thing is true here. So normally, our tangent function would rise on the right and fall on the left, but this is going to be the opposite. It's going to look like a cotangent function. It's going to rise on the left and fall on the right. Next thing, the 2. This is my b value. The b value tells us the length of the period. So the equation for period in a tangent or cotangent is pi over b. And our b value is 2. So our period is 1/2 of a pi. Well, the parent function's period is pi, so it takes a shorter amount of time for a revolution to occur. Then the last thing, what is the plus 4 going to tell me to do? Up 4. We're going to translate it up 4. There's a vertical shift. So now let's create where do our left and right endpoints occur. So here is our parentheses. That's our bx plus c. So we say 2x equals negative pi over 2. And we have to do the same thing we did on the left and the right endpoints for sines and cosines. We have to solve those for x. So what do I do to solve that first equation for x? Divide by 2. Or multiply by 1/2. So my first asymptote on the left side is at negative pi over 4. Then we do the same thing for the right asymptote. We set that parentheses, the bx plus c, which was 2x, equal to pi over 2. And we again solve it for x. So we divide by 2 or multiply by 1/2. And we get x equals pi over 4. So our first revolution, we have our left and right asymptotes. So here's negative pi over 4. Here's pi over 4. There's our asymptotes. We go to the middle between those two asymptotes. But we can't make the dot there. Where do we have to make the dot at? Up 4. So we have to create a horizontal asymptote. 1, 2, 3, 4. And that's now where our dot is going to go. So we have to move up 4 units. So here's where my halfway point is. There's a reflection. So instead of rising on the right and falling on the left, it's doing the opposite. And there is 1 revolution. It has a distance of pi over 2 for our period. And those are our asymptotes. That's 1 revolution. Are you comfortable with doing another revolution on your own? Add another pi over 2 and create the next. Because you'll have to do that on Friday for the quiz.